Hello everybody, it's Max McAllister from Traxxion Dynamics. There was a fella on the GL1800writers.com forum, goes by the handle of Johnny42, who posed a really interesting question, which is what does our engine case guard kit cost $300, and why does our set of tip-over protection moldings cost $450? And so probably most people have no knowledge of what it takes for the entire engineering process for an injection molded part, but I'm going to go over that with you and just let you know, just to give you an idea of the scope of the time and cost and effort it took to arrive at the first set of molded tip-over parts. But so one of the first things to clarify is our company, almost everything we make is made on a CNC machine. So using mills or lathes, and lathes turn round stock, and just like a traditional woodworking lathe, except we do it in metal, and a mill holds a block of something, and then a tool spins in it. Many parts require both machines to make one part. So sometimes you start it on one and finish it on the other. As far as developing something like an engine case guard, we have tools around here. If I'm working in, straight three-dimensional planes with dimensions of A to B, like say the spacing on an engine or a width under a motorcycle, these are things I can measure, depending on my level of accuracy required. When I'm prototyping, it could just be a tape measure that gets me started till we figure out how close we are. When we're measuring spacing for engine guard, we have a $600 vernier caliper that's 2 feet long. I can measure incredibly long objects down to the thousandth of an inch. So, but these are tools that are, $600 sounds expensive to somebody who doesn't need a tool like that. But for us, that's not a lot of money, and it does a lot of stuff for us. That's how we measure all the parts in our 4 cartridges. So we use a tool like that a lot. So we have the stuff here to measure those things that happen a lot in 2 dimensions, or maybe even stack up in 3. That's not a big deal. And then as far as programming CNC parts, you can go from my ideas on paper, and then I turn them into sketches with some forms of dimensions, or sometimes I even cobble up crude parts. And then they go out to a CAD man who takes them and turns them into solid models. That's generally one fee. From there, it'll go to 3-dimensional printing, where we get plastic prototypes printed, which is an incredible new technology that saves so much time and so much wasted time in the machine shop, because you used to have to machine parts, find out they didn't work, then go back to the CAD guy, but to machine the parts, you have to write programs. Programs cost money, a lot of money, take a lot of time. So we eliminate that whole step with 3-dimensional printing. Once we have a good 3D print and we know that the part's what we want, then we send it to a guy who does what's called CAM, computer-aided machining. He's a guy who has a piece of software that costs anywhere from $35,000 to $75,000. And he's, generally a guy like that is a high-level genius. And they take the 3-dimensional model and they convert it into a language that my machine can understand. That guy has to not only be a computer genius, a CAD genius, he also has to be a guy who knows how to take a block of metal and get a part out of it. So he has to be a highly qualified machinist. Those guys are a needle in a haystack. So, and then we go on to our machines. Once we've gotten to that stage, after that, we can make those parts in my machine shop, 100 at a time, or 200, 500, just depends on what the part is. And the setup and teardown, once we build all the tooling and we have the programming, we can make that part forever. Someone commented that we have plenty of plastic parts, and so I should be, it's not unfamiliar to us to be doing plastic molded parts. We don't have any plastic molded parts here at Traxxion Dynamics. Every plastic part that you see that we had is either laser cut or CNC machined. So in the world of injection molding, the tip-over protection kit was the very first thing to do that. So let's talk about what was the process and why is it so much more expensive. And by the way, this could happen with metal parts too. If you were to look at something like the casting for a fork leg for a Honda Goldwing, or if you're, think of the new tuning fork on the Honda Goldwing, that mold on the tuning fork on the front of the Goldwing, that thing, God, I'm not even going to guess what it costs Honda to make that. But they're only going to make a mold for a metal cast part if they're going to make tens of thousands of them for decades, right? For a decade or more. They're not just going to make a casting for a few hundred of these. That's why it's also a spectacular investment when you see the trike manufacturers have created the tuning fork at a different rake angle for trikes. So the difference is the cost of the mold. Now, you could say, well, what is that? A rubber part, that doesn't cost anything. It's true. The actual, once you can make one, that doesn't cost anything. That's not, but that's the uneducated person's view of an object. They just go, oh, that's not worth that price to me. But that's not how the things derived. So in the case of Honda, injection molding, all of these parts we had to destroy to arrive at this, that mold probably cost Honda, $25,000 or more to make this mold. Probably as complex as it is, it could have been $50,000. But Honda's going to make 100,000 of these things over the 10-year course of the life of the Goldwing. That mold is going to pay off over and over and over and over and over, right? So when Honda can sell this part for $25 because they're dividing it over 100,000 pieces. So here at Traxxion Dynamics, we might only get to make 1,000 of these before the Chinese have knocked it off. So I have to divide my development costs over 1,000 kits and hope I get to that point to theoretically then after 1,000 maybe make a profit for me. So, but what does that process look like? Well, remember I told you I could take measuring tools, common measuring tools a machinist might have, and measure things to make a metal object or get started. Here's where you start with a Honda Goldwing. There is nothing I can measure on this with common measuring tools. This is a complex surface. It's contoured in every angle in every direction. There's nothing a human being can measure other than I can say I want my part to be this long, about that tall, about that wide, and about that tall, and draw a shape. That's it. As far as fitting it to this surface, there is nothing I have or a CAD guy has that's going to measure that. It would take forever, and you would be going over and over. So what you have to do is you buy these set of these parts and you send them out to a company that does three-dimensional laser scanning. So again, now you're talking about an incredibly expensive machine, and I'm not going to buy one because I don't have enough demand. But so I hire that out as a service. So a company takes an object, whatever the object might be, they put it on a fixed platen, and then it can be at different ways where the platen spins or they move a tool, but they're going to move a laser, a tool, a gun that shoots an array of lasers out. Those lasers are going to touch the surface of the part and create what's called a point cloud, a cloud of three-dimensional data points that is millions and millions of data points, but none of them are connected. So after you pay for that service, now that file has to go to a guy with a piece of software that can surface the data, the point cloud. Sometimes it's the same guy, and usually that's the same guy. So now he goes to a different piece of software, and he's going to connect those dots, and that's called creating a surface. So once we have the surface, we've modeled the surface of this bag, and now, typically if I wanted to get a surface created in this bag, I'm going to spend about $3,000, something like that, for a surface this big. For the mirror, to create a surface like the mirror, you're probably talking in the $1,500+ range. Now they can mirror those surfaces in CAD, so you really can buy two and get away with that. Now I've got my two surfaces, but that doesn't have anything to do with building my part that I want. So now I got to send this surface to my CAD guy and give him my napkin sketches, my rough dimensions, and my ideas. He's then going to create that using, now he's got the complex surface created, and he can build a part out from there. So he's going to take his best shot at it. And then I'll approve it, I won't approve it, longer, shorter, so on and so forth. Once we get to some point, we're going to say, let's print those. Now we send those off to a company that does three-dimensional printing. By the way, there's, again, ignorant people that go, oh, you could just print those parts. You can't, because they just break. And printing is not for dropping things on it. It's for testing stuff. They are working on that, making stuff that's like this, but printing rubber for impacts, not really happening. So you go through printing the process. And so at one point, I intended to actually use an automotive molding on the mirror and blend it with a piece I made. But that just looked bad, and I gave up on that and said we just need to do the whole piece. So I had to have the mirror surface rescanned because I'd only had the end rescanned. So I had to have the whole thing rescanned because they didn't scan enough surface. So you go through printing, you get a part, you hold it up. What you imagined, it doesn't look right. It doesn't fit. It has to be bent. You go back to the CAD guy. CAD guy modifies it again. Then you print it again. It doesn't look right. To get this part to be as spectacularly, perfectly beautiful as it is and look like Honda put it there, we're not working with their model. We don't start with their model. We have to create our own on top of another surface. So that went over and over. We have boxes of failed parts. For months, this goes on. CAD guy, printer, failure. CAD guy, printer, failure. It all looks like shit and you got to do it over. So you start over. Finally, someday you may get to where you say, that looks good. I like it. That's it. Now, on this part, we actually had to put this on the bike, a plastic part, and then lay the bike over on its side. Now, we know we couldn't drop it on it because it would just break into pieces. But we had to find the widths, the heights, and things that would work. So my first concepts, long before we got to this, was to buy over-the-counter car auto body moldings. But there's no molding you can purchase that fits on this contour and looks right or even works. And I know there's going to be some, hammerhead out there that goes, I just go to the auto parts store and buy me up a molding and put it on there. It's not going to work. So I tried. I shopped every auto molding company in the world. You can't buy a molding tall enough to protect the Honda Goldwing. They don't sell one. So they're all lower and sleeker. They're not designed to hold it up and keep it from hitting the ground and rolling over. So that was another problem. Plus, when the bike falls over and smacks it into the ground, it's not the same as somebody pushing a grocery cart into your car door, right? You're actually dropping the motorcycle on it. So this door is going to deflect. When it does, if the molding isn't of the right height, the right dimension, and then it's still going to hit the ground and it will scratch the plastic above and below your molding. Ask me how I know. Well, because I had to buy multiples of saddlebag doors, right? 650 bucks a whack. We have piles of these around here. This is just some I grabbed just for the purpose of making this video. So I have thousands of dollars in smashed up Honda parts here. Thousands of them. We just bought them over and over. We put brand new parts on, throw the bike on the ground and smash it, right? How do you think I made a product that worked? There's only one way. You test a shark suit. Somebody's got to get in the water with a shark and let it bite you, and that's what we had to do with our bike, drop it over and over. Once we had parts that we felt would hold up the bike, we still hadn't found the material we were going to use. I intended for it to be a plastic that had some rubber content in it so that it would flex and would be able to be adjusted slightly by the owner so that it wasn't sensitive to being slightly losing its shape as it came out of a mold, which plastic can do, or if it got hot in a box, it might distort. So we were searching for the type of plastic. Well, in the meantime, our solid models go off to a mold manufacturer. Now, the company that does our injection molding happens to be in my hometown here in Woodstock, Georgia. I wanted all the parts to be made in America. The company they deal with for manufacturing molds, they said is the best in the world, is in India. They said, this is the best company for making molds. This is who you want to use. And they said, and plus it's much more affordable to be done in India. So I deal with the company in India and we start making molds. So the molds for our project here were $53,000. There's two molds. One weighs 800 pounds and is bigger than 3 of these boxes stacked up. The other one is the size of 6 of these boxes stacked up and weighs over a ton. The process for making the molds took months and months. They actually go through engineering and design where they have an incredibly elaborate piece of software that they take our CAD models, put them into 3-dimensional molds that don't exist in CAD, and then they can run different molten liquids into them and determine how it's going to work. They have these chromatographic arrays that show the colors of all the stuff and where it cools and where it might fail, where they're going to have to add vent holes and gates and all the stuff. This is stuff I had no experience with, way outside of my wheelhouse. So they determine a mold style that will work, where it'll go in, where it won't. Because it's possible you give them your design and they just say, you can't make that. Which, by the way, with the saddlebag protection is what they said. We can't make that. It's too thick of a piece of rubber. You need to hollow it out somehow. Well, in the case of the Goldwing, we were able to hollow it out so that it could ride over this ridge. So that worked. That worked for us. We were able to compromise and get a part that could be made. And so that was the whole process. That was a month and a half of time getting through that. Then comes the day when they say, all right, do you approve of what we've done here? And you have to say, yeah. Now, by the way, before you start, you got to give them half the money before they do anything. Now, then they actually go to buy, they take their blank, these giant tombstones, multiple layer tombstones that all bolt together to make your mold. And then they start building those. They start machining those. That takes a month or 2. I forget how long that took. They actually machine the molds. Now the molds are made. They put them on injection molding equipment in India. So then I had to buy a couple $1,000s worth, hundreds of pounds of various materials that they then inject into the mold and make samples and send to me from India. So then we tested all the different compounds that we found. So we came across this one that was just magic. And I'll never even say its name. But the magic compound is the one that allowed us to smash it on the ground, pick it up, wipe it off. And now instead of having a disposable part you would throw away for, I don't know, like I said in my other video, I don't know what people expected to pay. But if it was $250, like some people are like, well, I want to protect my whole motorcycle in 4 locations for $250. Anyway, okay, say it was that. Those are disposable parts you throw away. These parts I'm making, you're not going to throw them away. If your bike tips over, you're going to pick them up, wipe them off, and reuse them, even if they get moved away. So this was another big boon. So they put those parts in, they send them to me. What you print in CAD and what you make in the mold doesn't always work. Our mirror guard didn't work. Once you actually pour the part in the mold and let it cool, things don't come out of molds the size they go into molds. So the mirror guard was wrong. They had to remachine the mirror guard mold. That was some 6 weeks more time lost just to get 3 more millimeters of length so that the mold, the piece of rubber, would land right on the seam and look perfect like Honda put it there. If it had a gap like that, it wouldn't look right. That was 6 more weeks of time, more money, fixing the mold. So now I finally got the molds and we've run parts out of the material we want. Next, you got to pick a texture because in the mold, they're just shiny smooth. So I had to spend time down at the injection molding house going through these catalogs of thousands and thousands of surface textures, looking for the one that most precisely got our parts to look like the matte finish that you see on the Honda Goldwing. So that when you stand next to this, that part looks like that part, looks like that part. Because that's a texture. You don't see it, but it's there. By the way, texture isn't free. So just adding the texture into the molds was an additional $3,000. Surprise. So then they add the texture in. Then they send more samples. This is the final batch of samples. So then they send the samples with the texture. Everything's good. Then it's done. $7,000 to have the molds transported from India. I had them flown because it was going to take they estimated 2.5 to 3.5 months to send them on an ocean liner, if they would even get through with all the trouble people have been having getting ocean liners into the United States and getting goods into the United States. And that was going to cost $3,000. So I opted to have them flown on a plane so that I would be certain they made it here. And I got them, since I had, by the way, when they leave India, you had to pay 100% for them, and it's out of their hands. Whatever happens for them when it leaves India, now it's on you. So now I've got this set of molds. And at this point, between surface modeling, damaged parts, CAD, and the molds, I am at about $75,000 right so far. I haven't paid me a dime, and now I've been working for probably 1.5 years or more. We start going on what I thought was going to be the easiest thing, which was adhesives. I was completely wrong. We could not find anything that was going to make this stick in an automotive fashion, something that would be there 10 years, you know, the length of the bike, make it look good, not fall off. But more importantly, once we started testing was, since these, in order for this to protect the bike, it has to protrude a certain distance. But because it protrudes, and the way the bike is rolling over and hitting the part and rolling on it, it tries to tear the part off. If this part leaves that saddlebag, it's like it was never there, and the damage is exactly the same. It just knocks the part out of the way and tears it up. So that was another 2 saddlebag lids figuring all that out. So that was another $1,500 or $1,200, $1,300 are my costs. So then the adhesive thing went for 8 months. 8 months with an adhesive manufacturing company called a Converter, and they ran out of ideas because we couldn't get it to work the way it needed to, and so we had to get 3M Corporate involved from Minnesota. So 3M Corporate got involved. We got many more samples, some proprietary and special for this, and then we got very lucky, and our technician, you guys all know here, Jacob, one day did the Reese's Peanut Butter Cup trick where he put a special primer with one particular adhesive, and bam, that we hadn't tried. And that was the magic formula that made it stick like, I mean, it's on there. So that's what we had to have. So then we had that problem solved. And then we had to get them into the right color, into the right format, and made in a way that we can get them on and off. So the process with the adhesives was 8 months. 8 months of time. Until we got to the point where you guys saw a video where I took a bike kitted with our parts and finally dropped it on both sides and did not damage the bike. So that was 2 years of work. And at that point, that's where we got up into the $100,000 range between all of the development of the adhesives, shipping, next day or this, next day or that, on and on and on, damaged parts, all the stuff that's been smashed. And by the way, that doesn't include the first parts, the actual parts. I have a bill coming due for hundreds of sets of the molded parts and hundreds of sets of adhesives. That doesn't, all I'm talking about is what it costs to make one. Now, to apply these, if you come in here, these are applied by hand. It takes us a half an hour to get one kit packaged and get it into a box. So we have some fixtures we made to just locate the parts, but we apply those adhesives by hand. The same danger you have of sticking it in the wrong spot when you put it on your bike if you're not careful, we have here. If we put the adhesive onto the molding in the wrong spot, it's ruined. Now we can just peel the adhesive off and, you know, tear it off, clean it up, and put a new adhesive. But same thing, it's got to be perfect. If we don't put it on there perfect and it's hanging off the side, it's going to look terrible on your bike. So every one of those is done by hand. And by the time those 4 pieces are built, we package up the primers and we package up spare adhesives. It's 30 minutes to build one kit of time. So, you know, at $150 an hour, a half an hour of time in any work environment is $75 worth of cost to in the price of the kit. So that's why, I mean, and honestly, it's kind of tedious building these, but you know, so we kind of taken turns so far as we're doing them. So that's the real big difference. So if you took the first 1,000 kits we're able to sell and divided by 100,000, I've got, you know, you're going to see where the kit, the cost of the kits is going to be. I put $100 of cost for the actual process that got us there into it and into the cost of each of those. So it's been an arduous process, and again, somewhere at the end of the rainbow, I would hope to make money off of this. I mean, I don't know why it was a shocking proposition that someday I hope to make profit off this. So, but that's for me. In my imagination, 1,000 kits will take us probably 2 years to sell. So it'll be 4 years of my time, my money invested, my risk, and my effort, all before I make the first dime, right? So all the vendors that are making these parts for me, everybody's been paid, mold makers, CAD guys, everybody in the world gets paid. All the people making all the parts all get paid. But what about me, right? The guy who did this. So anyway, hopefully that gives you some insight into the difference between trying to start from scratch and manufacture an injection molded part, again, for complex surfaces, versus machining a metal object, you know, to fit known kind of square parallel surfaces. That's something that we can do much easier here. It's more inside of our wheelhouse. This was not going to be, there's never going to be metal objects, not from the get-go. When I looked at the bike, the last thing I wanted to do to that, Honda really went to a lot of trouble to clean that bike up and make it sleek and sexy. The last thing I was going to do was stick bars off the side of it and just trash it up. So, and make it look like some sort of Perry Dakar bike or something. I just wasn't going to do it. So anyway, you know, the other thing I wanted to say that was made me really happy. I purposefully played a trick before we were going to drop the bike. When I did a teaser video, there was 6,000 or 7,000 views on that video. Only 3 people, I purposefully walked right past our bike with the parts on it. Only 3 people saw the parts on our bike. That is, to me, was the greatest success. That means they are beautiful, hiding in plain sight, and no one can notice them. There's people that say they're hideous and ugly, whatever. It's just people that don't like me, and that's fine. I've grown accustomed to that. But there's no anybody in the earth can look you in the eye and say that's hideous and ugly, because they're just full of it if they do. That thing is awesome, and I'm quite proud of it. So we have decided everything is now available a la carte. We actually had some people say they just wanted saddlebag protectors. I don't know why you would want those and not the mirrors, but if that's what you want, so those are available individually on the site now. The mirrors are available individually, and the reason we did that was there are some bikes that have the decorative stripes embedded in the plastic. I could understand if somebody doesn't want the molding going through their decorative stripe. I get that, so we segregated that. The tip-over correction tools, somebody said, hey, I just want to fix my bent mirror, and somebody else said, hey, I just want to fix my bent crash guard. Those are available a la carte now too. So all the stuff you can buy in a piece at a time. And actually, once you've bought a kit, if you damage a piece of it, we will sell you the one piece in the future. That's not available on the site. You'll just have to contact us on that once we get further down the road with these, and hopefully, not hopefully, people tip their bikes over. But once someone unfortunately tips their bike over, we'll see if they need to buy a piece or replace it or something, or if they actually have a sliding crash where they're moving at 5 or 10 miles an hour and tear the things up. So, but we never know. So anyway, thanks for watching. My name's Max. I hope this gives you some insight into the development process and the costs that we've gone through to get this thing onto the internet for you to purchase. Please give this video a thumbs up and share it with your friends who are considering buying our tip-over protection kit. And we look forward to I'll bring you more great content in the near future.